Good afternoon. Hopefully everyone's been well fed. They say there's no such thing as a free meal. Well, actually, in this case, not only do you get a free meal, you also get to hear about all the exciting new things that are coming through with Atlas Search. Delivering this session, we have two fantastic individuals, one of which has come from a product designer background and brought forward that exposure to understanding customer experiences into the world of product management. The other, a thought leader with regards to the search technology, regular contributor to the Solar and Lucene projects. Some say one of these individuals actually discovered what the X-Files' Mulder and Scully were actually always searching for, and without full-text search. The other, apparently, had Einstein edit his theory of relativity twice. I don't know if that's true or not, but what I do know is they are the fantastic product management duo, El Schwer and Marcus Egan.
Alrighty, well, welcome everyone to our talk. My name is El Schwer. I've been with MongoDB for 4 years now, and I'm excited to be making my conference speaker debut in this moment. So if I stutter, it's nerves. I'm here with
Marcus Egan.
Who can say more about himself.
Yeah, I speak too much. So my voice is raspy, but it's okay. Excited to see everybody.
Yeah, so earlier today, you might have heard about the soon-to-be generally available facets feature with Atlas Search, and then Marcus led a talk about the product vision. So now we're going to talk about how we make this product vision reality with what's new in Atlas Search. So I will go to the next slide. We will be covering 6 different new features that we've released over the last year. We're super excited about these, but before we get in there, we'll give you a quick reminder of what actually is Atlas Search. So Atlas Search is our MongoDB's full text search solution built on top of Apache Lucene. It is a way to build fast, relevant, full text search in all of your data that lives in the cloud. Combining the power of Apache Lucene with productivity, scale, and resilience of MongoDB's Atlas fully integrated, fully managed platform. But you've probably already heard about us, so we'll get into the good stuff. What is actually new in this past year? The first one is all of our autocomplete improvements. So autocomplete is your partial search, your type as you go, your search as you go search solution. That's like when you start typing in Google and it starts predicting where you're trying to go. We've improved our autocomplete solution by making it available with our 40+ index analyzers. So now you can actually run autocomplete against any language that your data is stored in. The second improvement that we made is specific to boosting search results that match your exact text. So this is to make the top results a bit more obvious with what the user is actually typing in their code or in your search box. And then the third autocomplete improvement is letting autocomplete work auto-magically with languages that read right to left. So these are Hebrew, Arabic, as a few examples. The next feature that we introduced is our new search project index editor role. With finer-grained auth available, you can now more easily grant your team members the ability to configure search without having to worry about introducing additional security or operational risk to your system. We also introduced a handful of new search metrics. So there were 7. You can find these on your metrics tab, and these should give you the details and insights and telemetry that you need to feel empowered to use Atlas Search in production. I'm going to hand it off to Marcus now to talk a bit more about some of our newer, groundbreaking features.
So one of our most requested features is cross-collection search. And there's 2 sorts of cross-collection search we'll talk about, dollar lookup and union with, which are both available in Atlas today and the version 6 release candidate. Available to everyone. Cross-collection search with union with is really when you want to search for a search term across multiple collections in the same database. For example, I want to return all mentions of bagel, because I really like bagels. And that can be across several collections that all also have cream cheese. But you don't have to bring these into a single collection. Another one is lookup. Lookup is more like a join. So say I want to search purchases of a particular computer, but only of that specific user. Markets for Peace document, the Markets for Peace user in the user collection, and be a lookup criterion for the purchases collection where I'm searching. Next one we released was stored source fields. This is a more complex feature. This is really, you can think of it like a covered query and MongoDB, but really it's where we store fields in the Lucene index, the full value, so we can return them without doing an ID lookup. So if today, and there's a diagram I'll show you in just a moment, but today if you want to run a second stage after your search stage, which always has to be the first stage, like a match or a skip or a limit, and you needed to be very fast on a large result set, 40,000 is really where we start to see the performance gains, you'd want to use stored source. An example use case without stored source is I search for L in our employee directory. L's the doc ID where L appears in the employee directory in MongoDB. I return that from MongoT, and then MongoD does an ID lookup to actually retrieve the full document from MongoDB. You can understand why if we're doing that for every document for a sort operation, that could be expensive. Without stored source, and I want to sort on the importance field, where L would be the most important, I would store important, find L in the search engine, and return the values important to sort on those values directly from Lucene, deferring the ID lookup altogether in MongoD. Now, this is what the index definition looks like. It's pretty simple. You specify the fields you want to include in an array, or you can use exclusions. I recommend using include, but you can also exclude if that makes it simpler. You don't want to store, typically you don't want to store the entire document in Lucene. The query syntax is also simple. Return stored source is a Boolean value, so you can toggle between whether you want to return stored source true or false based on the result set. The final one is embedded documents. This is probably our second most requested feature. Stored source would be if people knew what it was, but embedded documents is probably our second most requested feature, which is the ability to search documents that are embedded in arrays. Lucene, by its nature, is a flat data structure, so it doesn't really represent nested documents and arrays as well as JSON. So to get around that, we introduced this feature to support multi-structured and flexible and evolving schemas in MongoDB. An example use case here might be the Airbnb sample data sets listing and reviews collection. In a listings and reviews collection, there's a reviews field that contains an array of review objects, individual reviews. So if you want to search on a date in one of these documents and the comments text, you'd have to use embedded documents. Limitations here are important. Lucene has a per shard limit of 2.17 billion documents, or 2 to the 32nd power. After that, the queries will not work. So you need to shard if you're going to hit that limit. And Embedded with facets is limited. It only works with strings. And there's a variety of reasons for why facets only work on strings and embedded documents. But to the 2.17 billion document limit, you need to be sure that the number of embedded documents are added to your total documents, because each of those embedded documents are considered one document in Lucene. So where your MongoDB document number might be 100 million documents, your Atlas Search document number could be 3 billion documents if you have, a lot of embedded documents in your arrays.
All right, so we are going to switch over to a demo. Where are we going? First, we're going to start in the MongoDB Atlas console. You've seen it. It's my bread and butter. So low risk. All right. So here we are in MongoDB Atlas. This is our fully managed cloud solution. As you can see, Marcus has a lot of search indexes in this cluster, but we're actually going to dip down into cluster 3, which is a deployment that has loaded the sample data set. So anything we do today, you can go home, copy, and do yourself, because it's the same data set that's available in MongoDB Atlas when you get started. And specifically, I'm going to play around in the mflix data set and the movies collection, which is a list of IMDb documents with some information about their ratings and the title, etc. But to get started with Atlas Search, I'm going to go over to the Search tab and create an index. Please excuse that. And this is just really to enumerate how quick and easy it is to get started with Atlas Search. So I'm going to click Create an Index. There are two options here. The first is a visual editor, which is your GUI-like experience. It's guided. It will make it easy to just click Create. And then there's a JSON editor for when you want to look at the raw index definition, kind of like a code box, and manipulate it for more complex indexing tools. So sticking with the visual editor today, I'm going to create an index on that movies collection that I had mentioned earlier today. And we're going to refer to it as MongoDB World. Next. So this page is where things get fun. This is right now set up to be just a default Atlas Search index using lucene.standard. So that is kind of a safe space for getting started if you are not sure exactly the best way to index on your data. But to just enumerate one of the autocomplete improvements that I mentioned at the top is the ability to now run autocomplete against any of these analyzers. I'm going to pick English because I don't know any other language, and so we're going to not risk that. And I'm going to add a field for the title field. I'm going to name it as a string so that we can boost for exact matches, and I'm also going to name it for autocomplete. I just noticed this is under lucene.standard, so we are going to make it English. And the reason why English is helpful is it's going to pick up on some of the obvious things that come with the English language. So it will automatically know not to index the A's and the thes and the conjunctions, and it can make intelligent decisions about words that have like run, runners, running. All of those really just point to the root of run. So with that, hitting Save Changes, Create Index, and that is it. Now there's an Atlas Search index available for me to query against using this movies data set. So I prepared one in advance so that we didn't have to wait for it to actually build. But if we go into the query editor, we have an area called the search tester. The search tester is just a place to test that your index exists, it runs, you can query against it. I'm going to do a really basic one, prints, see what results come back. And what you'll see is there's a score based on how relevant the search results are or the search system believes is to be against my query. You can expand that to see exactly where does prints appear within the search results. So we have cast, director, and writer, all prints. Guess this was one of his premiere movies. And then there's the ability to actually view the query syntax. So this is the query that was just run against the system. It's a simple text query going against all of the paths. I'm going to hit copy so that we can turn this into a bit more of a complex query using autocomplete. One other thing to note is there's the option to export to language. So if you are actually programming in a language that, like Python, Node, etc., you can click this and then copy and paste and get that exact command so that you can get started quickly. Moving over to the aggregation pipeline, this is just one representation of the aggregation pipeline. Compass actually just released a new user interface for this, so definitely would check that out as well. I'm going to paste that query that we just ran for prints, and you'll see we're getting very similar search results. And then just to make it easy for us to follow around, I'm also going to add a project stage so that you can see exactly the title field, which is what we're going to be running our queries against. So switching over to autocomplete, this is an operator. There's a handful of these. You can see the full list on our documentation. And I'm going to name the field title. The reason why I was erroring is because we don't have autocomplete set up against all the fields, just title. And you can see immediately we're starting to get some results. And the magical part being that now we can run queries as I type. And each time around, you'll start to see how the results are getting closer and closer to what I'm looking for. And so that's just a brief overview of some of the improvements that we've made to autocomplete. If I knew Hebrew, I would give an example of how we can now read right to left, but not my skill set. Handing it over to Marcus to take it a step further.
Or a step backwards, I don't know. Let's see how it goes. That was great, Elle, thank you.
No problem.
So now I'm going to try to walk you through the anatomy of a union with query, which is a cross-collection query, and there's some complexity. So I want to make sure that everyone here can follow along. And all the code and all the examples that you're seeing here, you'll have access to everything. We'll get to that in just a moment. But so we'll head over to the sample training database, also available in the sample data set, so everyone here has access to it, and the company's collection. In this company's collection, I can see some of the data that I want to search. I'm also going to open another window for the sample training database because we're working with two collections here. Going to open the inspections collection, where I'm not going to do much here, just using it to browse. Now, to get back to that aggregation page where it was before, head over to search. And so the search here is going to look pretty similar to how it always looks at first. So there's no index name here, which is a bad practice. That's why I like Elle's presentation, but I'm using the default name. And I'm going to search for license number. In the overview of the companies. So here you can see Yakun Media in Germany. Based in Berlin, actually, love that place. And there's Nose Rub. I don't know what kind of business that is, but it's there. And then the Etelos, I'm not sure what they're about either, but interesting. Now, the next step here is where we're going to introduce union with, which is a stage that's been in the aggregation pipeline for years, but now we're repurposing it for All right, let's search. In the union with query, you need to specify the collection that you want to union with and the pipeline that expresses your filter criteria or your query. So we'll want to union with inspections. And we'll want to know, we'll want to run a search query again. But this one's embedded in this union with. So previously, before, you could not use search as a sub-pipeline. Now you can. So we'll do text here, query, license. I want it to be the same, because let's just assume we have a single text box, and that text box is going to send this query down to both of these collections. So we'll just have the exact same query. Uh-oh. Business, short name. Let's see. What is the name? This is why I have this other field. That's right. Business name. It's there. An unknown error.
I wonder if it's working in the aggregation pipeline.
Oh, I know what's wrong. It's because, so this pipeline is still a pipeline. So the same syntax applies. Right? And so now you have, thank you, L, aggregation pipeline here. Now, the problem is, after we ran the query, you notice Yakun Media is still there. And our favorite company, Nose Rub. So the problem is that when you do a union with the search, the outer search is returned first, and then the inner search is returned second. So we have to do a little bit of manipulation. I'm going to try to run through it pretty quickly just so we have time for questions. I'm going to do a few things. I'm going to add a field so that you can see which collection search results come from, and also so you can understand how to reorder them. So I'm going to change this just a little bit. Oh, fun. Unknown error. Oh, I know. Sorry. My bad, everybody.
All good.
You know it's a real demo. So I'm going to add this field. So now, boom. Now you'll see in here, in the source, it should say it's coming from the overview field. It's buried in here somewhere. We don't have to dwell on it. I'll project it later. Then next, we have the union with, and we'll need to set a field. We need to set a field that is source. No. Sources companies. And this one is interesting because we have this pipeline array here, we can just drop it in right here. So it's a real aggregation pipeline in the union with. So now we've added it. Now we still don't have the right order of results because you can still see Yakun. So now we're gonna do project again. Search, score. And then the score is gonna be, and in just a moment, something like that. Oh, I added another dollar sign. So now you can see the scores. What's interesting about this one is you look at these scores here, and it's 3, 3, 2, 2, 2, but no documents from the other collection. So then we have to do a sort on this field, on the score, and then you'll start to see the other fields. Score, -1. And now you're starting to see documents from different places, and I can prove it with this. Oh, this is a project, sorry. Yeah, you ready? And this is how it works. We're not going to look at the documents because it's a long time. But these are documents from all of the places. From both of the collections. Overview, only overview there, but now inspections. After we've sorted by score, we have inspections, 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 inspections. Inspections were more relevant. And then overview, and then another inspection. So yeah, that's cross-collection search.
Cool. Well,
Sorry.
it's all good.
It's complicated.
The merits of live demoing, very stressful. Do you want to? And that was just one example of the many features that we are introducing today, but there are more, and when I get to the QR code, you will see it. But before we get there, I just want to end with this quote from a VP of engineering from a company called GoodFind. They are using Atlas Search today in production to help users find food from food trucks, one thing that I really look forward to when they expand to New York City. They tested both facets and stored source fields, which Marcus taught us about early on today. And with that feature, they experienced impressive gains in their backend performance and scale. So that is it. I hope you realize how easy it is to get started and maybe how it can get a little bit more tricky when you're trying to run complex queries, but we do have the support and tools that you need to get there. We have a handful of new Atlas Search content that you can use to help connect the dots, including in the new Practical MongoDB Aggregations book, there is an Atlas Search examples section, which gives code for how to run many of these queries, as well as a new tutorial for how to build e-commerce content catalogs with Atlas Search. And with that, this is the aforementioned QR code, and thank you for joining.
Developer productivity, faster results, and more relevant documents. So remember that.
Thank you, El. Thank you, Marcus, for a great session. Do we have time for questions?
One question.
One
Two
question.
questions. What's up?
Coming over.
Run, Vivek, run.
I have a question regarding special character search on the, like when you
Special
autocomplete.
character search.
Yeah, like a lot of times what we have is, dashes and stuff like that in our search, and they don't really well. They don't do well on the searches. Like the scores are all over. It's not really. I mean, do you have any suggestions on that, or?
Yeah, so there's two ways to approach it. Historically, how people have dealt with special characters. The first way is you can use the white space analyzer, right? So if you want to break only on white space, tokenize on white space, ignoring the special characters so they're not stripped, they're still preserved. Like say you want to search on hashtags, right? the hashtag symbol is still preserved in the white space analyzer. And there, Elle just pulled it up. Thank you, Elle. And then the second approach is a custom analyzer where you can use white space or even regular expression capture or other patterns, keyword. There's a lot of ways to deal with it, but the custom analyzers are another option. Any other question? That's good?
Yeah, I mean, just the scores are not always accurate.
Well, the scores being accurate is different from the special characters causing a problem. I think you have to work with them to try to understand why the scores are the way they are. They're always, I mean, they're accurate mathematically, like they're calculated, right? So, I mean, we can talk about boost strategies and what you want to do, but it takes some time and a lot of reading. We hope to make it easier. We're working on it.